The purpose of this video tutorial is to cover the basics of beam design in a two-way slab or a one-way slab and beam environment within Adapt Builder. In this example, we're going to set up a hybrid structure which includes part of a one-way slab with beams and also a pure two-way slab with beams on frame lines. So we'll go ahead and begin. We've opened the program in Adapt Floor Pro with Edge, and we've also disabled the post-tensioning. So this could also apply to a post-tensioning structure or a post-tensioned structure, but in this case this will just be an RC structure. So the first thing we'll do is we'll build a very quick model here. We're going to use some of our grid settings in the UI in order to make this happen. So we'll go ahead and do that now. And we're going to have a grid in the X direction, 5 bays at 25 feet. We'll use the build toolbar to just place some columns. We're going to assume all of the columns here are 24 by 24 square. So we'll go ahead and change the shape to a square shape. These are 24 inches, and we're going to place these at 25 feet on center. We'll have 6 columns. In the other direction, the first bay is going to be 28 feet. So in this Y direction, this is 28-foot increments. So we'll just put in the first bay of columns. I'll go ahead and now just take these columns. I'm going to copy those using copy move, and we're going to copy those in the negative Y direction 32 feet. And I'll copy those again in the negative Y direction 28 feet. So we have 28, 32, and 28. I'll turn off my grid. And the last 2 bays here are going to be a one-way slab with beams. We're going to assume all of the beams in the model are 22 by 30s. So we'll go ahead and add a beam under Build, Structural Components, Beams. We're going to change the width to 22 inches and the depth to 30 inches. Now obviously you can modify this and make whatever beam sizes are necessary in your model. Again, we're just using the same size for simplification. If I turn on the Snap to Endpoints tool, I can then snap to place the beams. Now you'll notice that when I snap first and then second point, the beam is placed. I then have to snap an additional first and second point. If we use the chain tool, which is shown here as the continue mode, we can just snap, and this is a continuous secondary snap. We'll just say close that and exit, and we can use that mode to more rapidly create the beams. So we have beams along each of the column lines. I'm going to now just take this and copy this. So I'll go back to Modify, Copy Move. I'm going to replicate this in the negative X direction 25 feet 4 times. And I'll go ahead now. Rather than using the Build pull down, I'll go to User Interface, open the Build toolbar, and I can do the same thing here. I can create beams, and again in this case I still have the continue mode or the chain mode turned on. So I'll go ahead and stop that. I can create a new beam line, and these beams actually stop here. Let's exit. So I'm just right clicking to exit in this case. We'll right click and exit, and I will get rid of those 2 beams there. So we have a two-way slab and a one-way slab with beams. The one-way slab will be 6 inches. So we'll go ahead and add a slab. I'll change its properties to 6 inches. And I'm just going to model it on the center line of the beams that have been placed. Had a little bit of a problem there. We'll go ahead and move that. and then I'll change the thickness, add a new slab, which is 7 inches for the two-way system. Okay, and we have our model now. Now if I take section cuts, you can see I can verify geometry at different sections. So let me turn off the continue mode, and I can take these cuts through different regions of the slab, place the insertion point, and it will show me what the cut looks like. And this is good for visual validation of what you're modeling. Also, in some cases you may want to model and move the slab to the exterior of the beams. So in this case, I'll go ahead and I'll take this slab. I'm going to turn on the option for snap to vertices of components, which now allows me to snap to corners, and I can just move this over like so. In this case, I'll select both slab regions and I'll move this point up, and you'll notice I'm unable to select the midpoint unless I turn midpoint on. And now I can select the midpoint of that column, and we can go around and change the extent of the slab rather easily using some of these snap tools. And we'll do one more on this side. Okay, so we have our slab and our columns and beams. Our model looks something like this. If we wanted to account for the stiffness of the columns above, I could select by type all of my columns, or I could change the view of the structure to a front or side view. Just select my columns and copy those vertically. So I could use the toolbar to copy move vertical. This is from the Story Manager toolbar. Or I can go to modify, copy and move vertical. I'll copy this up one time, and now I have columns above and below. We'll now go ahead and add some load to the model. So I'll go to loading. So under loading, load case library, or I'm sorry, add load, we're going to add a patch load. The patch load, we're going to define the properties as dead load. We'll say that this is 20 psf of dead load. This is superimposed dead load, and we're just going to place that over the entire slab. And you'll notice that this point at this corner missed the snapping. That's okay as long as it covers the slab. I'll just make sure it's more accurate and move it. In that case, we'll go back to loading, add load, and we're going to add now live load. And there are other types of loads you can add. In this case, we're just going to add uniform dead and live, and we'll say the live load is 50 psf. And again, we'll snap to the 4 corners of where we want the load to be placed in this case. If I rotate this to a 3-dimensional view, you can see we have our live load and our dead load placed on the structure. The self weight will be automatically calculated. In order to design the beams, we need to now set up what we call support lines. The support lines dictate to the program how the design should be carried out, whether it should be carried out using two-way slab criteria, beam criteria, or one-way slab criteria. And this model has essentially all 3 inside the model. So we have the need for first setting up our support lines. We'll start over here on the one-way slab. So we're going to have a beam line. I'll go ahead and go to strips, create support lines. We want to create support lines in the Y direction first. We're going to use this opportunity to create the lines along these girders or these beams. So we'll change the direction to Y direction, and we'll start over here on this side, and I'll go ahead and snap on the center line of the column support, and we're just snapping from column to column to column. And notice that the beams are also snapped to the center lines of columns in this case. That's probably the most fundamental way that you can enter the beam geometry. Realistically, the beam is not that long, but analytically, Again, this may be the easiest way to model the beam. The program does support you modeling beams anywhere in proximity to the column, but again, for this case we'll simplify and use this option for centerline modeling. So along this kind of shares one-way slab on one side and two-way slab on the other. So the beam is still considered a beam design. We'll go ahead and snap again on the center line of the supports. Now one thing you'll note is that each of the support lines that we just added, if I double click to open the properties for this support line under the design is set to two-way slab. So those really should be designed as beams. So we're going to go ahead and change it to beam, and I'll change this here to beam. And again, this, if I click on this once, you'll notice it's actually opening the beam. If I press tab, it selects one slab, press tab again, the other slab, press tab a fourth time, and now I have the support line selected. And if I go ahead and open the properties again, we can designate that as a beam. Okay, we'll go now and do the remainder of the beams in the Y direction. So preemptively we're going to select the option to create a support line, but now I'll go here and make sure that this is set to beam, Y direction. And now we have the support lines. Two more will be added. For the last support line, I'm going to artificially set that to what we call a two-way slab, and in terms of the criteria. So we'll go back once we're done adding this, and I'm going to set this one to two-way slab. So I'll select the support line. I'll go here to the Y direction, or I'm sorry, to design, and we're going to set this to two-way slab. And I'll show you how this affects the results that are output by the program. In the X direction, we have a hybrid system. We have a we have a beam line which belongs to this slab, and then we have basically a one-way slab. So we're going to separate the two. We're going to go ahead and go back to strips, create support lines. I'll go ahead and say that this is going to be a beam. For the direction, we want to make sure that this is switched to X direction, and we'll do the same process, modeling from column to column in this direction. And I'm going to terminate that and press C to close, and we'll repeat that step for the remainder of the columns, or the beams in this left side of the slab. I'll go back and fix those 2 points. The snapping is quite sensitive, as you can see. We've had 3 mishaps there, so we'll go back and just stretch these. We can always go back, select the support line, and just move the points back into position. Okay, so those are all designated as beams. We now need to generate our one-way slab strips. So I'll go back to strips. Under create support line, we're going to again make sure this is the X direction. For the design, this will be a one-way slab. Now for a one-way slab design, I need to I can arbitrarily select the spacing of the actual strip. So we might use a unit strip of 1 foot, 2 foot, 3 foot, 5 feet. In this case, we're going to use a unit strip of, let's say, 4 feet. So we'll go ahead and I'll take this, I'll modify, I'll copy it, and we're going to copy it -4 feet. And this is going to be 7 times, actually 6 times. We'll say copy. I was right the first time. We need 7 of these, so let me do that one more time. We'll go -4 feet again, and copy. Okay, then we'll go and do this 8 times, so I'll take that again. I'm just spacing it every 4 feet, so this is 28, 32, 28. So this will be 8 copies. We'll go back to modify, copy move, negative 4 feet again, and this will be 8. And for the last one, I could do something like so. I can just say select these. I'll use under modify copy move by translation, so I'll select the center point of that column and the center point of this column, say copy, and that moves those into place. So we have arbitrarily spaced one-way slabs that are every 4 feet that span from beam to beam over on the right side of the model. On the other side of the model, it gets a little more tricky in terms of how we have to structure this. So we have a beam, and if we were to go ahead and just generate the design strips now, the tributary of this beam would extend halfway to the next frame line. So we have to tell the program where we want our middle strips. We have essentially column strips here, but now we're going to define the middle strips. In this case, the program can technically generate middle strips for us. If I go to criteria under analysis and design options, I can have the program generate column and middle strips when I'm working in RC mode. I have it selected to no right now. The reason is column strip, middle strip works really well with a two-way slab, but I also have a one-way slab with beams on the other side, and there's no way to differentiate the two. If I apply the column middle strip, the program is going to create a middle strip in between each of the already designated one-way slab strips. So you're basically going to get an additional set of support lines in the one-way slab direction, and in addition, in the one-way slab region for the beams, you're going to get a middle strip that's going to cut between the two beams. So you'll have a beam line, a middle strip line, a beam line, a middle strip, and a beam line, which isn't exactly correct in how the one-way slab beam system works. It applies to the left side of the model but not the right. So because of that, we have to manually input our middle strips. And I'll go ahead and do that. I'll go back to strips, create support lines, and I'm going to create a two-way slab support line now. So now we've gone from beam to one-way slab now to two-way slabs. And for these, we're going to go ahead and start at the perimeter of the slab, and I'll just snap to the center line, and we need to make sure that this is in the X direction. It should be X. Yeah, that's okay. Close that. I'll snap to the center line of the beams that are intersecting these two-way slabs. And I'll do the same here. And I'm also going to do the same for the Y direction. So we'll go back to strips, generate our strips, or create our support lines, I'm sorry. Go to the general direction and change this to Y. We're still working under the two-way slab criteria, and so we'll go back, just snap on the center line of that beam on the edge of the slab there, and do the same thing in this direction. Now I think I may have forgotten to add one point on that second line. I'll go back and add that. Okay, so back here, if I click on that, I want to snap on the center line of the beam and the slab edge. So I'll take this and just snap it out here, and then I'll go and add a point. Now, one thing you may see is you'll notice that every one of my support lines stops inside of the perimeter of the perimeter of the slab. There's a tiny gap of about 1 inch, and that's going to cause a problem when we generate our strips. If I go to the modeling toolbar, we'll go to modeling toolbar, and the modeling toolbar allows us to essentially generate strips like we were just doing. One method is just the pull down, the other is the toolbar, but it also allows us to extend support lines to slab edges. So if I select all of my support lines, I don't need to do it one by one. I can just go to select by type, support lines, and I'm going to go ahead and click that option. All of the support lines should now be snapped out to the edge of the slab. Okay, so we have our support lines created. We're now going to generate our design strips and our design cuts. Our strips are essentially our tributaries for the design. So we'll go back to strips, generate the design sections automatically. We'll regenerate the tributaries, and we get a array of in both directions of design cuts that are perpendicular to each of the support lines that we just added. Now, to see this more clearly, I'm going to use the Report Plans toolbar. I'll open this toolbar, and you can see there's a design strips in the X and Y direction. If I click on the X, it will show us the hatching of the strip. So this strip here, support line 7, is a beam strip. We have a beam which has a flange which is essentially half the distance to the next support line. The user has control over that distance. If you wanted to trim that distance so it might be only at the face of the actual beam, there's a way to do that using what we call splitters, and I'll show you how to add a splitter on a couple of these beams so you can use that in your own work. But you can see the support lines in the X. We have much less wide support lines here because these are the unit one-way strips over on the right hand side. I'll toggle this over now to the Y direction, and again we have essentially column line, middle strip, middle, column, middle, and then we have a beam here. So the column strips that I'm referring to are really a beam strip, but in terms of two-way slab design, they're essentially a column strip along the frame line, the supports. Now let's assume that we want to limit the width of the flange on these perimeter beams on the top and the bottom. So I'm going to introduce what I call a splitter to do that. A splitter is just a virtual boundary which the program uses to terminate the tributary to it. It's a boundary that is regarded only for purposes of generation of tributaries. If I go to strips, I'll go to create a splitter. Because the strips that we're going to be manipulating by use of the splitter are in the X direction, the splitter needs to be labeled as an X direction splitter. The splitter, we're going to start at the slab edge, and I'll use snap to nearest, just arbitrarily assuming that we want to eliminate essentially the entire flange off of this beam on this top and the bottom. I'll go to the opposite end and I'll terminate this at this slab edge. We're going to do the same thing for the bottom. And again, I'll stop that there. Now if I go back and regenerate my strips for the model, you're going to see in the X direction the tributaries for support lines 34 and support line 36 have grown. They've essentially engulfed the area that was displaced due to us adding the splitter. You can see the splitter is at the exact location where support line 10's tributary is cut off. The same thing at the top. So we've manipulated those two strips. We'll just leave those as they are now. The other thing we want to be mindful of with this model is the support line that we added at the far left in the Y direction. So this support line is technically called a two-way slab support line, even though it's really a beam. So if we mislabel, or if we have a situation where we might have a hybrid support line where two spans are two-way slab, one span is a beam, another span is a two-way slab, it doesn't always require us to break the support line up. If we go to criteria and we use analysis and design options settings, you can see there's a setting that says design all beams using their respective building code requirements for beams. So even though that support line at this edge is labeled a two-way slab, the program recognizes that there are beams along its path, and analytically, from a design standpoint, those beams will be designed as beams. However, the reinforcement placement and the reinforcement sizing is respective of a two-way slab setting in criteria. So under the referred or the preferred reinforcement sizes, the program will actually use the two-way slab reinforcement size versus the beam reinforcement size. And we'll go back and just change some of these criteria. We'll say we're going to use 7s and 8s for beams with number 4 stirrups, and for two-way and one-way slabs we'll use let's use number 6 bars for two-way top and bottom, and we'll use number 5 bars for one-way. And we're now going to process the model. So we'll go back to FEM. We want to first mesh the model. We have to mesh in order to solve this program or the problem. So we'll mesh the slab. We'll now go and analyze the structure. And we're going to analyze just to a default set of combinations. So we'll select the option to not include vibration. We'll just deselect, turn that off, and we'll go ahead and run the model. Once the model is completed in terms of running, the analysis will go back to FEM. We've already generated our design sections. Those are currently shown. We're now going to design the design sections. So we'll design them. A design section is a generic term. The design section could be set to a design criteria of a beam, a one-way slab, or a two-way slab, like we've shown. If a design cut or a support line in general includes a beam, an actual physical beam, then we would typically set that to a beam design criteria. Go ahead and save that. So once the design is completed, we could always go into the result display settings here and check, for example, for strength, dead and live. This is just one of the ultimate load conditions. We may want to check what the bending moments are along our strips. So we've selected bending moments. I want to turn on the design cuts in order to see the results. So I'll use user interface, support line, results scale toolbar, and we're now going to turn on the design cuts. And here we can view the moment diagrams, or for example the shear diagrams for these particular design sections. In this X direction you can see we have column, middle, column, middle. In the other side of the slab we have one-way slab strips. So the moments here are much smaller than the moments here, only because the line of integration over which we're determining these forces is much smaller than on the left-hand side. So using the support line results toolbar, I'm going to select the 1, 2, 3, which is also the numerical display, and this shows me the value of shear for each of these support lines, or moment, or axial force, or whatever it is we're interested in viewing at that time. So these are the actions that the program designs the sections for. And again, a section could be a slab, it could be a beam, it could be one-way slab or two-way slab. In this case, again, we have all three. We're going to now go and generate our reinforcement. One of the fundamental items in the program is being able to understand how the program represents the reinforcement, especially in terms of having beams in a model. So I'll go to FEM. We've just designed the sections. We know what the design is. Now I want to actually see what the reinforcement is. We'll go to Generate Reinforcement Drawing. And I'm just going to generate this currently for the strength dead and live combination. So we'll turn that on. And in this view, you're going to see a lot of different colors. You're going to see blue, green, and red reinforcing. Now this looks very, very difficult to read and interpret, but we're going to filter this so we can actually understand what the program is reporting. The first thing I've done is I've gone to default display. That gets me back to this bare slab. I'm now going to open the reinforcement toolbar, and we're going to focus on using this toolbar in terms of filtering what we want to view. So I'll select the rebar display options, and let's assume I only want to display rebar in the bottom of the slab or the bottom of the beam along the X direction. So we'll do that first. The program is going to report to us the reinforcement in every single one of the strips that we've created. So a strip equals design sections or data points, and for those data points we want to know what the reinforcement is. The text is a little large over here in these Oneway Slab strips, so I'll go back to Select Set View Items. Under the Reinforcement or the Rebar tab, I'll change the symbol size. I'll cut that in half, and I'll scale the font size down to 12. And we'll focus first on the Oneway Slab. So for the Oneway Slab, the reinforcement is shown in terms of distribution, distributed bars. The distribution is the width of the design strips, which we said arbitrarily was 4 feet. So each one of these slabs, you can see, has so many pieces of rebar associated with it. Now you can see that most of the rebar is spaced at 8 inches on center. That triggers right away the thought that this rebar is actually being controlled by minimum spacing, which, if we go back to criteria, this is under the rebar roundup spacing. Right now the program is checking if the spacing required for strength does not meet a specific minimum value, then or maximum value, then the program essentially reverts back to the maximum value and uses that as the spacing. So here I'm going to disregard this. This means that the spacing check won't be applied when we generate the rebar. I'll go back, regenerate this for, again, strength dead and live, just to simplify again. And we're going to see all of the reinforcing. I'll go back here just to reset the view, just select the rebar display options, and now you can see that the spacing is actually at 16 inches on center. So the 8 inches was what was required for spacing. This is truly what's required to meet the demand moments due to strength dead plus live. So we need 4 bars spaced at 16 inches on center. These are distributed over the width of the section, and this is pretty consistent over that entire bay 1 and bay 2 of this Oneway slab. On the left side, we'll start with the middle strip. The middle strips, for example, this is a two-way middle strip. Again, bottom rebar is always represented in the form of distributed bars. So over the middle strip width, the program shows you the distribution of number 6 bars at 38 inches on center. At the beams, if we go back and turn on our design strips, we can see this support line is labeled a beam. Because we're in RC mode, the program is showing the bars as being distributed on plan, but in reality the depth of that bar is truly in the effective depth of the beam. How can we view that? If I was to take this bar and this beam, and I'm going to isolate the view of those two. So I'll just display those two items, and I'll go to a front view of the slab or of the model. You can see the beam is actually placed at the bottom of this, or the bar is placed at the bottom of the beam. That's the effective depth. So even though the program in plan shows it being distributed over the width, these bars belong inside the beam because of its assumption for effective depth. I'll go back, show this rebar again, and if I do the same thing for the slab instead of the beam this time, I'll go ahead and isolate this. Oops, let me go back to this view. Okay, we'll try that one more time here. And I'm going to isolate that selection. Going to a side view, you can see that bar is actually placed in the depth of the slab. So it's related to a slab. The program knows if there's a beam there that the effective depth is in relation to the beam, not the slab. We'll go back to our reinforcement display. So the most important point to take away from that is even though the bar may be shown as distributed on plan, these bars belong to the beam. They should be placed within the beam width in this case. If I go ahead and isolate the other direction, the X direction, for bottom reinforcing, you can see the same thing would apply. The bars that are associated with a beam design strip or a design cut that intersects a beam, those bars are relative to the beam depth, not the slab depth. If we go over to this side, the same thing applies. This is just a shorter distribution than over on this side because we have now a middle strip here. We'll go back to the top reinforcement now. We'll go to the X direction top rebar. And the top rebar for an RC design in the program is typically shown as, again, distributed. So you can see the top bars over the beam are shown distributed, and because the slab and the beam, the top of the beam are at the same elevation, the distribution would just occur in the slab. The slab engulfs the beam, or the beam engulfs the slab in this case. So all of the reinforcement here is shown as distributed as well, and would be placed over the width of the actual flange of a T-beam, or the design strip width in more generic terms. Now if we take any of these design strips, let's go and clean the view. I'll turn on my design cuts again. Let's just use this as an example. If I double click on that beam and I select this option to show an elevation, I'll go ahead and create an insertion point. The program is going to show us a lot of information here. It's going to show us the design criteria is a beam, the load combination is strength dead and live. I've produced the reinforcement only for that combination. I could have produced it for envelope and it would show me essentially the same information, just presented as the envelope combo, and the rebar would likely be different because now we're including the service rebar or minimum rebar. But this view is going to show us the longitudinal bars and the stirrups and their spacing. So this is a way for the user to generate output that this can then be exported to a CAD file for use in presenting on drawings. Another option would be if we were to go into the reports menu and we go to single default tabular reports. Under the design section data, we can also present the reinforcement in the form of a tabular report using the design section rebar tabular report. This is another way that we can present reinforcing. If we wanted to, we could show all of the rebar in plan as we previously did, and this could be exported to a CAD file. So whatever is shown and presented in this view could be exported from File, Export, DWG, DXF. To control the font size and coloring of what's presented in CAD format, If we go to User Interface and turn on the Rebar Draft Plot Detail toolbar, that toolbar will allow us to then set up and prepare for the DWG DXF export. So here we can change the colors of the top and bottom bars or the top and bottom mesh, the font size, and the symbol sizes. If we're printing a report or printing a view for reinforcement out of this window, to change the fonts and that for printing either to a physical printer or, for example, PDF, we would then use the Select Set View Items under Rebar to change the symbol and the font size. One more important item is to show you how to verify that a beam is actually being designed as a beam in the program. So we're going to go ahead and clean the view of the model. I'll go back to the design sections, and if we double click on any section in the structure, we can go to Design Sections. Under this Design Sections tab from the Support Line property box, we can validate what section is being used in evaluating or designing the reinforcement. And in this case, we have a physical section which cuts through both slab and beam. We have a T section. The program uses the idealized section here in the second image, and it shows a representation of reinforcement needed for that section to meet the demand or the minimum requirements for reinforcing. If we select details, the program will show us the mechanical properties of the section that are being used in evaluating the section for design. So this is a great way to validate the section and to see what the program is specifically using in terms of the physical makeup of a section and also the criteria that's being used along with associated values. For additional information, please contact ADAPT at www.adaptsoft.com, or you can always reach out to our support group at support@adaptsoft.com. Thank you.